Good afternoon. Welcome to Dynamic Engineer's video training session on LC, custom LC filters. Again, this is part of our custom crystal factory capability. And both types of products are manufactured in our same location. LC filters, unlike crystal filters, can handle many watts of power, up to 200 watts of power. When your customer starts talking about many watts of power, right away you start thinking that LC filters is one possible solution in their application. Considering our RF system block diagram, I always go back to that. Always refer to your RF system block diagram just as a conversation piece with the customer. You'll notice that the RF filter, that's the filtering mechanism just before the transmit, just before the carrier frequency is transmitted to the world. The RF filter portion is near the power amplifier, and both of them work in conjunction to get the right output power for the transmit frequency with the right attenuation of out-of-band frequencies. So LC filters are usually associated with the portion of the radio in the transmitter section because it's many watts of power versus crystal filters, as I said earlier, that are just a few milliwatts of power, less than 10 milliwatts of power at the input and at the output. LC filters, as a result of the high power, they come in dramatically different package sizes. If you look at our product brochure, we've listed a few design examples, 6 design examples, and the package size, the length and width varies dramatically. 135 by 25 millimeter, 44 by 16 millimeter, 22 by 10 millimeter. Some are leaded packages, some are surface mount packages with castellations. Usually, all of the LC filter applications involve very high reliability products. Not only in military radios, but in medical devices, such as ultrasound machines. Custom LC filters are used in ultrasound machines to enhance the quality of the images through the electronic processing chips, the analog to digital conversion chip, the microprocessors and the DSPs and the FPGAs. The bottom line is, if you have some medical instrument, ultrasound type equipment, MRI machines, our factory is qualified in a couple of those applications, and it usually involves a custom LC filter. Now, the LC filters we try to promote, of course, have a large degree of value-added testing already done on them. We guarantee that the LC filter network will maintain its electrical parameters over a very wide operating temperature range. We can provide hermetic seals so that the packaging is moisture proof for a given application. Sometimes the customers will say, no, that's okay. I just am going to design the LC filter function of my radio or application. I'm going to design that discrete LC function as part of my motherboard. I don't need a packaged part. Always try your best to help the customer understand that buying a sealed component from a filter expert is always going to be a better solution technically. It's going to have a tighter distribution because our filter engineers, of course, are experts. Computer modeling is done very extensively. The distribution of parameters is going to be very tight, and it's going to minimize the variation of the LC filter function block on the customer board. If it's an external component designed externally, yes, it may cost a little more, but if it's a high reliability application where quality is the #1 priority, those customers might be swayed to allow a discrete LC filter component to be designed into their application. LC filters go from 20 megahertz, they can go all the way to 6 gigahertz depending on the material properties selected for the L's and C's. But we can definitely go up to 6 gigahertz of operation. And as I said in an earlier video, we have an in-house machine shop that can handle any kind of mechanical configuration the customer desires. In addition, like the crystal filters, we have an LC filter bank capability. What I mean by that is either tunable LC filters or individual LC filter subsections in which a pin diode switch network is used to software switch between the different LC filter subsections for frequency hopping radio, software defined radio. Again, we have already established designs of LC filter banks, multiple sections, maybe 6 sections, maybe 8 sections. In the frequency range, most common, for example, for military radios, 30 megahertz to 88 megahertz or 30 megahertz to 512 megahertz. All with different center frequencies, all the different LC sections in a very large package filter bank assembly, where the switching electronics is on the underside of the board, software controlled. We can do these value-added modules, and again, as I made allusion to in another video, we will not usually present a generic data sheet for those. Competitors, they like to show us what they're working on. That's great. We certainly appreciate it. But our customers are very sensitive to their radio architectures being exposed to other competitors. So they're very sensitive to having their data sheet published on a website. So we will work with you for a custom application if you come upon one. It is not a problem. Thank you very much.